Hello, in this video I will do 8 examples of solving exact differential equations. So this is all about solving exact ordinary differential equations or exact equations. So what is an exact equation? So a first order differential equation of the form m of xy plus n of xy of dy over dx equals 0. So it's almost like similar to the last section we went over. The last section was on a linear first order differential equation. The only difference is the right side is now 0, right? That's pretty much the difference. So if you have it in this form, uh, and the only difference is there's not a dx, or there is a dx. I'm sorry, this is missing. Yeah. So the only difference between from the previous lecture is on the right side is equal to 0. If you have it in that form, then you know it's an exact equation. So if it's in this form, you know you have an exact equation. And there exists a function of f of xy whose differential equation to the left side of this. Okay, so the theorem is theorem m of x comma y dx plus n of x y dy equals 0 is an exact equation if and only if my equals to nx. So just like in the previous section, we had to prove that my does equal to nx. So it's the same thing for this one. So how do you solve? Steps are for finding for solving exact differential equation. First step is put it in the correct form. Step 2, verify that my does equal to nx. And then once you do that, you can integrate m of xy dx and n of xy dy to find a potential function. So let's start with example 1. Determine if the equation is exact, and if it is, determine its general solution. So this one, we have parentheses, 5x plus 4y dx plus 4x, parentheses 4x minus 8y cubed dy equals 0. And they don't give us an initial condition, right? So first step is, are we in the correct form? So let me write this. So on step 1, are we in the form of mx comma y plus n comma x comma y dy equals 0? I believe we are, right? This whole thing is your m. This whole thing is your n. So yes, so it does check out. We are in an exact form. So step 2, determine does m of y equals n of x. So my m of xy is pretty much this thing, 5x plus 4y, right? And does m, if we take the derivative in respect to y, or the partial derivative, it would be 4. So if you recall in partial derivatives, if you take it in respect to y, anything that does not have a y is a constant. So the derivative 5x is 0. The derivative 4y is just positive 4. And then what is our n of xy? It's pretty much this whole thing, 4x minus 8y cubed. Right? And then if you take the partial derivative in respect to x, anything that does not have an x, if you take the derivative of that, is 0. So this negative 8y does not have an x, so it's a constant. So the derivative of constant 0, and then the derivative of 4x has an x, so that would just be positive 4. So does my equals nx? Yes, it does. ny equals to nx. 4 equals to 4, so it checks out. Okay, so now we move on to step 3. We just have to take the derivative, not the derivative, the integral of the integral of mx y dx and the integral of nxy dy. Okay, so let's go ahead and do that. So the integration of this is basically the integration of 5x plus 4y dx. And then the integration of this is the integration of 4x minus 8y cubed of dy. Okay, so let's take the integration of this in respect to dx and x. So, right, so what is the integral of 5x? In respect to x, that would be 5x squared over 2. When is the integration of 4yx? It does not have an x, so you have to add one, right? So it's just going to be plus 4yx. And then the same thing here, but we are taking it in respect to y. So what is the integration of 4x in respect to y? So it does not have an y, you have to add one. So it's going to be 4xy. Minus, what is the integration of 8y cubed? It does have a y, so you have to use your power rule. So 3 plus 1 is 4 over 4. So that's 4xy minus 2y to the fourth. Okay, so now what you have to do check is if you have something, you have to have something in common. If you don't, then we made a mistake and this problem does not work. So do we have anything that's the same? Yes, we do. We have a 4yx, or really you could say 4xy, and you have a 4xy here. So if you have a repeating term, just write it once. So you write out the 4xy only once. Okay, so we have 4xy, and then we have this 5/2 x squared. And then we have this, this we just write it once. And then we have this a negative 2y to the fourth equals c. Now we don't have an initial condition, so we don't have to solve for c. So we could just leave it like this. So this is your final answer. Not too bad, right? Okay. Let's move on to example 2. So example 2 says determine if the equation is exact, and if it is, determine its general solution. So we have parentheses 2xy squared minus 3 of dx plus parentheses 2x squared y plus 4 parentheses dy equals 0. So first step is determine if we have it in the correct form. If it can't, then we can't do this problem. So is it in the form of this? Yes, because we have this checks out, this checks out, and then the right side is equal to 0, so they all good. So yes, we do have it in the correct form. Okay, step 2. Does m of y equals n of x? So let's first find m of y, or what is my m of xy? My m of xy is this whole thing, 2xy squared minus 3. 2xy squared minus 3. And then you just take the derivative in respect to y. Let's see here. So anything that does not have a y, it's just a constant, right? And that would be 0. So over here, this is one term. This has a y. This has a term of y. So just apply power rule. So 2 times 2 is 4. Leave this x alone, right? That's just a constant now. And then it's going to be y to the 1. The derivative of negative 3 does not have a y, so it's just going to be 0. And then you have n of xy, which is this whole thing, 2x squared y plus 4. Okay, so take the derivative in respect to x. So this whole term, this is one term, right? It does have an x, so you just apply power rule. Just leave this y alone because it's a constant. So 2, that would be 4x to the 1, and then you have a y. The derivative of 4 of a constant is 0. Okay, so it checks out. It checks out. So why did I say? Yeah, so my does equal to nx. Perfect. Step 3, take the integral of both sides. Take the derivative, the integral of m of xy and the integral of nxy dy. Okay, so this is going to be the integral of 2x y squared minus 3, and we take it in respect to x. When I say in respect to x, meaning everything else is just a number. So let's see here. We're not taking the derivative of the integral, right? So this has an x. It's going to be, so this has a power 1. So you just take your integration rule. This y squared is just a constant, so just ignore it. Just take the integral of this x here. So that would be, this has a power 1, so 1 plus 1 is 2 divided by 2, and then everything else is a constant, so bring that down. So that 2's cancel, so you're left with x squared y squared. And then the same thing here, we're taking the integration in respect to x, so that it does not have an x, so it's just going to be negative 3x. Okay, over here, it's going to be the integration of 2x squared y plus 4 dy. Okay, so we're taking the integration in respect to y, so this has a y, this has a power of 1, so just do your integration rule. So it's going to be 1 plus 1 is 2 over 2, and then the rest is just a constant, so bring that down. And then the integration of 4 is just 4y. Okay, so the 2's cancels, and then you're just left with x squared, y squared, is 4y. Okay, now what we do is check if we have something we're repeating. We do. That means it does work. So our repeating is x squared, y squared, x squared, y squared. So just write out the repeating once. So it's going to be x squared, y squared, and then bring down your leftovers. So our leftover is negative 3x, and then plus 4y. And then that equals to c. And it's your final answer. Okay, example 3. Determine if the equation is exact, and if it is, determine its general solution. So we have the integration, we have parentheses 2x plus 4y plus 4 cosine xy of dx plus parentheses x cosine xy dy equals 0. First step, is it in the correct form? I believe it is, but let's see. So is it in the form of this? M of xy dx plus n of xy dy equals to 0. I believe it is because the right side is 0, this is good, and this is good. Okay, it is in the correct form. So then step 2 is does m of y equals n of x? So first, what is our m of xy? It is basically this whole thing, right? So that's going to be 2x plus y cosine of xy. And then we just have to take the in respect to y. So, and remember, we're taking the derivative in respect to y. So if it does not have a y, it's a constant. So this 2x does not have a y, so the derivative constant is 0. Over here, how do I take the derivative of this in respect to y? See how there's the two products? Uh, you're most likely going to do the product rule, right? So yeah, we're going to use the product rule. My f is y, my f prime is 1, my g is cosine of xy, my g prime is negative sine of xy of x. And then you just apply the product rule. So it's just going to be, product rule is f prime of g plus g prime of f. So m of y is equal to f prime is 1, g is cosine of xy, plus g prime is negative sin of xy of x, and then f is y. So if you clean that up, that's going to be, we could put this in front, so this would be negative xy sin of xy plus cosine of xy. Okay, and let's find, let me just kind of like box it. This is not our answer, but I kind of let's box it. Now let's find n of x. So my n of xy is going to be x cosine of xy, right? It's basically this whole thing. So what we have to do is take it in respect to x. So unfortunately, we have two terms that are multiple, two terms that are multiplying each other. So we're going to use most likely the product rule. So my f is x, my g is this whole thing. So f is x, f prime. The derivative of x in respect to x is 1. Our g is cosine of xy. The derivative of g prime of this in respect to x is negative sin of xy. And then we're taking it in respect to x. So the derivative, so you kind of take the chain rule and you're basically taking the derivative of the inner parentheses in respect to x. So the derivative of x is 1, and then y is a constant. So that's why you just bring down this y. Okay. So when you put it all together, you should get negative xy sin of xy plus cosine of xy. So my n of x is going to be, so does n of x equal to m of y? Yes, because m of y is negative xy sin of xy plus cosine of xy, and then my n of x is the same thing. Okay. Okay, next step is take the integration of both sides. Okay. So we got to take the integration of 2x plus y cosine of xy of dx, and the integration of x cosine of xy of dy. Okay, how do I take the integration of this in respect to x? Well, the integration of 2x is 2x, this has the power of 1, so 1 plus 1 is 2 over 2. The integration of this is in respect to x is, yeah, you gotta, so this, like there's two, you're taking, this is that one whole term, right? So you would have to take the integration of this. Did you know that's very similar to y? So y, we're taking it in respect to x. Everything else is a constant. So did you know this is very similar to, you can like say integration of 5 cosine of 3x. And uh, so how do you would have to do the u substitution, right? So let's do that. So your u, so it would be the integration of y of cosine xy. And what will we do? We do u substitution. So my u is xy, and then du in respect to x would be uh, y, right? Right. Yeah. So du in respect to x, here you have your x. This does not, this y is not an x. So the derivative of x is 1, and then this y is a constant, and then you have a dx. Good. Everything is good. So this is going to be cosine of u, and then you can replace this. You can replace y and dx with du. And what is the integration of cosine? It is positive sin of u, and then you just replace your u with xy. And then over here, the 2's cancel, so you're just left with x squared. Okay, the same thing here. My u is going to be xy. My du is, so we're taking it in respect to y. So my du would be, so here you have a y, the derivative of y is 1, and then if you don't, this x is a constant, so bring it down, and it comes out nicely. So that would be the integration of cosine of u, and then you replace your x dy with du. And the integration of that is sin. And then it's going to be sin, you just replace your u with xy. Okay, there you go. And then as you can see, we do have something, a repeat. We have a sin of xy, a repeat. So it's going to be sin of xy plus x squared equals to c. There you go. Okay, let's move on to example 4. Okay, so example 4, determine if the equation is an exact, and if it is, solve the initial value problem. We have 2xy minus 9x squared plus parentheses 2y plus x squared plus 1 parentheses dy dx equals 0, where y of 0 equals 3. So this time we do have an initial condition, right? So we got to plug in, we're going to have to do an extra step. So first step is determine if it's an exact solution, if it is in the correct form, right? So is it in the form of this? Not quite. It's not quite in the form of this. What I would do is, this is good. We have a dy, but we don't want this dx on the bottom. We have to have it, we have to, this dy is good. We have to somehow get rid of this dx. So how do I get rid of this dx? You can multiply all 3 sides by dx, right? So that's what I'm going to do. I'm going to multiply everything by all 3 sides by dx. This by dx. So if we do that, this now becomes parentheses 2xy minus 9x squared dx plus over here, the dx cancels, right? And then you're left with 2y plus x squared plus 1 dy. And on the right side, 0 times dx is 0. Okay, and then now we have it in the correct form. Okay, step 2. Does m of y equals to n of x? So my m of y is, or my m of xy is this whole thing. 2xy minus 9x squared. And if we take it in respect to x, so this term has an x, the derivative of 2xy in respect to x is 2 yeah, it's just 2 2x. And then the n of xy is 2y plus x squared plus 1. So the n of x is, well, I made a mistake. This should be n, no wonder I was n of y. So the derivative of this in respect to y, so this has a y, the derivative of y is just 1. So you're just left with 2x. And then over here, this in respect to x, this does not have an x, so the derivative of that is a constant. The derivative of x squared is 2x. This is a constant, so yes, m of y does equal to n of x. Okay, let's move on to step 3. So the integration of, now we got to take the integration of both sides, so m of xy dx, and the integration, the integral of n of xy dy. So the integration of m of xy is 2xy minus 9x squared dx. So the integration of this is, so we're taking not the derivative, but the integral in respect to x. So this one, this has an x, this has a power of 1, so take your integration rule, so that'd be 2x, and then 1 plus 1 is 2 over 2, and then you still have this y, bring it down. The integration of 9x squared in respect to x would be minus 9x, 2 plus 1 is 3 over 3. And then over here, the integration of 2y plus x squared plus 1 of dy. This has a power of 1, so that's 2. 1 plus 1 is 2 over 2. This does not have a y, so it's going to be, so that you treat the x squared as a constant, so it's going to be x squared y. This does not have a y, so that would just be the integration of 1 in respect to y would just be y. Let's see if we can clean this up. So over here, this 2's cancels. So you're left with x squared y minus 9 over 3 is 3x cubed. Over here, the 2's cancel, so you're left with y squared plus x squared y plus y. Now, do you see a repeating term? I do. I only see, yeah, I see a repeating term of x squared y, and x squared y. You just write that out once. And then bring down your leftovers. So our leftovers are negative 3x cubed plus y squared plus y equals to c. Now, step 4, we do have an initial condition, so we got to do plug initial value. Of y0 equals to 3. So we have an initial condition of 0, 3. So go ahead and plug that x for 0 and plug in y for 3 into this. So that's going to be 0 square 0 times it by y is 3 minus 3, and then 0 cubed plus 3 square plus 3 equals c. So this is 0, this is 0, this is 9 plus 3. 9 plus 3 is 12 equals to c. So this c is 12, so you can rewrite this problem as x squared y minus 3x cubed plus y squared plus y equals to 12. And then what you do next is you move this 12 to the left. So you're going to subtract 12 from both sides because you have to remember, if you put it in this, it says you have to put the right side to 0. So that's why we have to move that 12 to the left. We get x squared y minus 3x cubed plus y squared plus y minus 12 equals 0. Okay, example 5. Example 5 says determine if the equation is exact, and if it is, solve the initial value problem. So we have this whole thing. I'm not going to say it out loud. You can see this. Do we have it in the correct form? No, we don't, right? We do not have it in this form. What you have to do is I think you would be good. You see this right here? If we move this to all that to the right and move it here, because this has a dy, you can only get all the dy's on one side. So let's get all the dy's on one side. So should I FOIL with this too before I do that? Go ahead. This would be 2x plus 2y of dy, and then just move all that to the left. So that's subtract 2x plus 2y dy. Okay, so on the left, you have x, y squared plus x minus 2y plus 3 of dx. And then on this, you kind of like collect like terms, so it's going to be like x squared y dy minus 2 parentheses x plus y dy equals 0. You can't really collect, so this is like negative 2x minus 2y. So you can't really collect like terms, but you could say, you could just put them all like one in parentheses, right? So it's going to be x squared y minus 2x minus 2y of dy equals 0. And then over here, this stays the same. We have xy squared plus x minus 2y plus 3 of dx. Okay, now we have it in the correct form. So this is our m, and this is our n. Step 2. Does m of y equal n of x? Let's see, my m of xy is what? This whole thing, xy squared plus x minus 2y plus 3, and then just take it in respect to y. Take the derivative in respect to y. So here we have a y squared, so the derivative of that would be 2xy. This does not have a y, so that's that's like a constant, and the derivative of constant 0. This one would be the derivative of negative 2y in respect to y would be negative 2, and then 3 is a constant, so yeah. And then my n of xy is 2xy minus 2. So my n in respect to x would be, so this has an x, so that would be 2. Oh, wrong. Oh no, no, this is wrong. I think I gave you the answer of it. So my n of xy is x squared y minus 2x minus 2y, right? And then my n in respect to x would be 2xy negative 2, and then this does not have an x, so it's just 0. So does m of y equals n of x? Yes. Okay, step 3, you're going to take the integration of both sides, or take the integral of m of xy with respect to x dx, and then take the integration of n of xy of dy. Over here, this would be the integration of x y squared plus x minus 2y plus 3 of d of x. And then this would be the integration of x squared y minus 2x minus 2y dy. Okay, let's look here. What is the integration of this in respect to x? So this has an x. The integration of that would be 1 plus 1. That'd be just use your power rule. So 1 plus 1 is 2 over 2. And then you still have that this does not, this is like a constant, so bring that down. The integration of x would be, this has a power 1, so that would be x2 over 2. The integration of negative 2y, that does not have an x, so it's just going to be the integration of negative 2y in respect to x would be negative 2xy. The same thing with this 3. It does not have an x, so you're just going to be plus 3x. Now let's do this, but we're taking it in respect to y. So this has a y, so this is 1, this has a power 1, so it's going to be x squared, y squared over 2. This one does not have a y, so it's just negative 2xy. This one here would be negative 2y. This has a power 1, so 1 plus 1 is 2 over 2. So if you kind of, what? Oh, so this cancels. These two cancel, so you're left with negative y squared. X squared, y squared, 2 minus 2xy. Do you see anything that they have in common? I see, yes, this is a common thing. And this is a common thing, negative 2xy. So this time we have two common things, which is okay. You just have to write it out once. So it's going to be 1/2 x squared y squared minus 2xy plus 1/2 x squared plus 3x minus y squared equals c. Now, do we have an initial condition? Yes. So step 4, you're going to plug in your initial condition. So it's going to be 1/2, and then my x is 1, so that's 1 square minus 2 times 1 plus 1/2, 1 square plus 3 times 1 minus 1 square equals to c. So it's going to be 1/2 minus 2 plus 1/2 plus 3 minus 1 equals to c. And then if you calculate 1/2 negative 2 plus 1/2 plus 3 minus 1, that gives you 1. So 1 equals to c. Okay. So it's going to be, your final answer will be 1/2 x squared y squared minus 2xy plus 1/2 x squared plus 3x minus y squared minus 1 equals to c, which is positive 1. And whoops, this, I put an extra negative 1 here. This should be not 1, but we have to get this side 0, so we do have to subtract negative 1 from both sides. So I'm going to get 1/2 x squared y squared minus 2xy plus 1/2 x squared plus 3x minus y squared minus 1 equals to 0. There you go. There is your final answer. Okay, let's move on to example 6. So example 6 says determine if the equation is exact, and if it is, solve the initial value. So we have dy over dx equals x y squared minus cosine x sine of x all over y parentheses 1 minus x squared, and we have an initial condition of y of 0 equals to 2. So this is slightly different, but the process is still the same. So what I would do, since it is in a fraction, maybe I should cross multiply. So that's what I would do. I would cross multiply. So this is going to be y of 1 minus x squared of dy equals this whole thing. Is it in the correct form? Whoops. Is this in the correct form? Not quite. We just have to get this side 0, so you're going to have to subtract we're going to move all this to the right, so you're going to subtract this whole thing. Okay, so now you have negative this cancels. If you want, you can distribute this minus, so this would be negative xy squared plus cosine of x sine of x dx. Okay. Now, is it in the correct form? It is, right? Uh, so this whole thing is your m. This whole thing is your n. So step 2, does m of y equals to n of x? So my m of xy is negative xy squared plus cosine of x sine of x. And then we're somehow supposed to take it in respect to y. So take the derivative in respect to y. So this has a y, so that's going to be negative 2xy to the power of 1. And then this is going to be, oh, this does not have a y. So if it doesn't, that's just a constant. So the derivative constant is 0. So this is just 0. And then my n of xy is y of 1 minus x squared. So take that in respect to x. So this is a constant. So basically, you take the derivative of this. So it's just going to be negative 2xy. Or you could FOIL this. Yeah, I should have done that. FOIL this y. So this is going to be y minus yx squared. And then if you take the derivative of that in respect to x, this is a constant. And then this is going to be negative 2xy. So does my equal to n of x? Yes. Good. Step 3, I'm going to take the integration of both sides. So this is going to be negative xy squared plus cosine of x sine of x of dx. And then take the integration of y minus x squared y of dy. So let's start here. What is the integration of this in respect to x? You could break it into two separate integrals if you like. So this would be integration negative x y squared of dx. It's the integration of cosine x sine of x dx. So this integration of this in respect to x is negative 1/2 x squared y squared. The integration of this, you would have to do like u substitution. Your u would be sin of x. Your du would be the derivative of sine x is positive cosine of x dx. So that would be the integration of u du. And that is going to be 1/2 u squared. So that's going to be negative 1/2 x squared y squared plus 1/2, and then you replace u with sin square of x. Now let's do this. We're taking the integration in respect to y. So the integration of y in respect to y is 1/2 y squared minus the integration of this whole thing, negative x squared y would be negative 1/2 x squared y squared. You bring that down. Now, do you see a repeating term? I do. I see this is a repeating term. So is this. So you just write out your repeating term once. And then bring down your leftovers. Your leftover is 1/2 sin squared x plus 1/2 squared equals to c. And then what do I do next? Do we have an initial condition? Yes, we do. So step 4 is, again, your initial condition. So we have y of 0 equals to 2. So that really means your x coordinate is 0, your y coordinate is 2. It's going to be negative 1/2 0 squared, 2 squared, plus 1/2 sine squared of 0 plus 1/2 of 2 squared equals to c. So this whole thing just becomes 0. I believe. Yeah, I believe sine of 0 is also 0, right? So this becomes 0. And then over here, we have 2 squares, 4 divided by 2. That's 2. So 2 equals to c. Okay, so your final answer is negative 1/2 x squared y squared plus 1/2 sine squared x plus 1/2 y squared equals to 2. And then subtract 2 from both sides because you have to get one side 0. Your final answer is negative 1/2 x squared y squared plus 1/2 sine squared x plus 1/2 y squared minus 2 equals to 0. Okay. Okay, so what if it wasn't an exact equation or an exact form? So there's a way you could do how to make a non-exact differential equation into an exact equation. So if m of y minus n of x all over n is a function of x alone, then mu of x equals e to the integral of m of y minus n of x over n of d of x. If n of x minus m of y over m is a function of y alone, then that's a repeat. So then so what you would do is multiply each term in the differential equation by the integrating factor mu in order to turn it into an exact differential equation. Then solve this new exact equation using the method for exact differential equation. Form is still your first step, so you still got to put it in correct form. So let's do example 7. So example 7 says solve the differential equation by making it exact. So we have parentheses xy dx plus parentheses 2x squared plus 3y squared minus 20 dy equals 0. So I think it is an exact form, right? It is in the form, it is in exact form. But if you do step 2, does m of y equals to n of x? So my m of xy is xy. And then my n of xy is 2x squared plus 3y squared minus 20. So my m of y, the derivative of this in respect to y is x. And then my n of x, the derivative of this in respect to x, so this would be 4x to the power 1. This does not have an x, so that's a constant, so that's just going to be 0. The same with this is a constant. So they do not equal the same, right? M of y equals x, n of x is 4 of x, not exact. So what you have to do is do n of x minus m of y all over m, and that gives you, so my n of x is 4x, minus my m of y is x, all over my m, which is xy. And if you kind of clean this up, 4x minus x is 3x, and then on the bottom it's xy, and then as you can see the x cancels, so you're left with 3 over y. So this is your, then what we have to do is put it in the mu form. Then you got to find mu, which is e of this, of, yeah, e, we just found it. So e, so your mu is going to be the e of the integral of this whole thing, which turns out to be 3 over y dy. And what is the integral of 3 over y dy? Well, 3 is a constant, so you could take that out. So that's 1 over y dy. And then this is the ln of absolute value y, and then you have this 3. So you have mu, which is e, and then the integral of 3 over y is 3 ln. And I don't think I'll drop the absolute value. I'll just use parentheses y. Now, can you cancel the e and the ln? Not quite yet. This 3, you can't just leave that there. So remember when you're expanding logs or natural logs, if you have a number in front of the log or natural log, that's a power. So that's going to be e ln of y to the third. Now you may cancel the e and the ln. So your mu is y to the 3. Okay. Then step 2, you're going to multiply everything by mu. Okay. So you're going to multiply everything by mu or multiply everything by y cubed. So it's going to be y cubed of xy dx plus y cubed of 2x squared plus 3y squared minus 20 of dy. And then on the right, it's going to be y cubed times 0. So clean this up. This is going to be x y to the fourth dx plus over here, if you FOIL this out, you should get 2x squared y cubed plus 3y to the 5 minus 20y cubed dy equals to 0. Now check. Now recheck. Does m of y equals to n of x? So my m of xy is x y to the fourth. So my my is 4x y to the third. My n of xy is 2x squared y cubed plus 3y to the 5 minus 20y cubed. So my n of x is going to be, this would be 4x y cubed. This does not have an x, so that's 0. This does not have an x, so that's 0. So do these equal each other? Yes, it does. So now it is exact. So your new, so your new exact is x y to the fourth of dx plus 2x squared y cubed plus 3y to the 5 minus 20y cubed of dy equals to 0. So what we do next is take the integration of both sides. So the integration of x y to the fourth in respect to dx, and then the integration of this whole thing. Okay, so the integration of xy to the fourth is 1/2 x squared y to the fourth. The integration of this in respect to y is going to be 1/2 x squared y to the fourth plus 1/2 y to the sixth minus 5y to the fourth. So your final answer, you have a repeating of this whole thing. So that's going to be 1/2 x squared y to the fourth plus 1/2 y to the sixth minus 5y to the fourth equals to c. Okay, let's do one last example. Okay, example 8. Solve the given differential by making it exact. So it is in the correct form, right? We have a dx, dy, and the right side is 0, but does the m of y equal to n of x? I don't think so, because m of xy is this whole thing, 3xy plus y squared. So my m of y is going to be 3x plus 2y. And then my n of xy is x squared plus xy. My n of x is 2x plus y. So they don't equal each other, right? These two do not equal each other. So step 3, integrate factor. Basically, what you do is you do n of x minus m of y all over m. So my n of x is 2x plus y minus my m of y, which is 3x plus 2y all over m, which is 3xy plus y squared. And when you clean that up, that's going to be 2x plus y minus 3x minus 2y all over 3xy plus y squared. So on the top, it cleans out as negative x minus y over 3xy plus y squared. And then on the top, negative x minus y, it looks like you could take out a negative 1, so that would be x plus y. And then on the bottom, it looks like you could take out a y, so that's 3x plus y. So this is the y alone. Now you do the x alone. So the x alone is m of y minus n of x all over n. So that is going to be, my m of y is 3x plus 2y minus my n of x is 2x plus y all over n, which is x squared plus xy. So that's going to be 3x plus 2y minus 2x minus y all over x squared plus xy. So if you clean this up, it would be, the top would be x plus y, and then the bottom would be x. You could factor out an x, so that would be parentheses x of x plus y, and that gives you 1 over x. So this is in terms of x alone. So now what you would do is find your mu, which is e of the integral of my minus n of x all over n. So that's going to be e of the integral of 1 over x d of x. And we know the integration of 1 over x is ln of x, so it's e ln of absolute value of x. So the e and the ln cancels, so you're just left with x. So your mu is e to the x. Okay, then what you would do is multiply everything by mu. So this is going to be x 3xy plus y squared of dx of x squared plus xy dy equals x times 0. So when you FOIL this x out, it's going to be 3x squared y plus xy squared of d of x plus over here, this is going to be x cubed plus x squared of y of dy equals 0. So this whole thing is your m, and this whole thing is your n. So does m of y equal to n of x? So your m of xy is this whole thing, 3x squared y plus xy squared. So my m of y is 3x squared plus 2xy. And then my n of xy is x cubed plus x squared y. So my n of x is 3x squared plus 2xy. Yeah, it looks like they're exact. So then what you would do is your integration of both sides. So take the integration of 3x squared y plus xy squared in respect to x, and then take the integration of x cubed plus x squared y of dy. So the integration of 3x squared y plus xy squared in respect to x is x cubed y plus 1/2 x squared y squared. And then the integration of x cubed plus x squared y dy in respect to y is x cubed y plus 1/2 x squared y squared. So do you see a repeating term? Yes, this and this. So you just write that out once. Plus, oh, look, I also see another repeating term, this one. So that's going to be, just write out that once, equals to c, and we do not have an initial condition, so this is our final answer. Okay, that wraps it up for this section, so I'm going to stop here.